Saxon Advanced Mathematics, Lesson 2. Buckle in, students. This is a bit of a wild ride. I'm sorry. There's not much I can do except push through it, and we will. And trust me, after a couple of these rough lessons, our pace will settle down and it will feel much more normal again. So this isn't the new normal. Before we dive into the content, I want to just review some housekeeping details, remind you of what I know you already know, but it just bears saying again. One thing you'll notice at this level in our textbook, there are no practice problems. Now, you may be clicking your heels with glee and thinking, thank God, that's just one less thing to do. That's true, but that means that the new material is buried in the homework rather than sitting right up there at the top. So you will distract yourself with other problems and then get down to the end, closer to the middle / end of the problem set and be like, oh, crud, there is the new material and I don't remember anymore what that was all about. Okay, so that's fine. You'll have to just go back and figure it out. But you don't have to worry about practice problems. The other thing is that, those little reference numbers that are by each problem to tell you where it was originally taught, those are not in the textbook. In order to find them, you have to look in the solutions manual. I'll show you, just let me write this. And you write it too, right? Because everything I write down, you write down. So here's what I'm showing you. Here in the textbook, there's no little numbers in parentheses. Curses. But if you go to the solutions manual, which I happen to have right here, now, I just opened it randomly, but see, for every problem number, it shows you there the reference to the lesson where the concept was first introduced. There it is up there. Okay, so it's kind of a drag because it's just one more step when you're already frustrated to go, oh, I have to look in the solutions manual, but it's fine. They're there if you need them. Okay, once we get through this first couple weeks, we will resume our normal pace of lessons where you'll watch the lesson and do the problems. And we'll always do the odd problems. Okay? The odd problems have the answers in the book. But at this level, you guys almost always are going to want to use that solutions manual to get a better picture of what's happening in the problem and how to stay on track. So I don't imagine that you'll use the answers in the back of your textbook as much as you will rely on that solutions manual. We will be working the odd problems except for this first week, which I'm going to explain again just to make sure you're with me. Instead of having 4 different lessons, we're doing one, and my suggestion is that you do the odds, and then you do 1 and you do the evens, and now we're starting lesson number 2, and you'll do the odds, and then you'll do the evens. So we're getting 2 homework assignments out of each lesson. We're doing the regular number of problems, but we're just doubling up in order to digest this material. It's kind of a lot happening all at once. So this is a way that I can get our work pace up to speed without drowning you in too much content too fast, okay? So hopefully you've already ticked these 2 boxes. Now you're ready to start these. I also gave you the discretion. If you want to do the evens first and then the odds, that's fine with me. Or if you wanted to do something like problems 1 through 15 and then 16 through 30, that's fine too, except it wouldn't be through 30 because we are not doing those concept review problems. So I think it's 28. You could do that as well. But By the end of the week, you'll have done all of the problems for lesson 1 and all of the problems for lesson 2, minus concept review, which, as I said before, those are old SAT format style problems, and the SAT doesn't test like that anymore, so there's no need for you to do those problems. Okay, and then just a reminder that when you're doing your homework, the first thing you do is work the problem. Then you check the answer. And again, you have 2 sources for this. You can check the answer in your textbook or in the solutions manual, whichever you prefer. Then you fix your answer, fix your mistakes. Let's say that. If your answer is right, you don't have anything to fix. But you stop right then and there and fix the problem. If you can't fix it, you ask me, and there's 2 ways you can do this. You can text me immediately, or you can ask at the video check-in. Okay, some students prefer to find out right away what's going on. Others consider it like a weekly task of asking me all of their follow-up questions and getting everything straightened out. Okay, so you have 2 options for doing that if you're stuck, right? If you can't fix your mistake yourself. In the end, you're going to mark each answer as correct. When it's correct, obv, mark each answer as correct. You have your own choices here. You can do a smiley face or a star or a heart or an arrow or, old school check mark, meaning yes, you got it right. This is what your parent is looking for, is they review your homework. And so if it's a different color, that's a big help. And then when you get everything done and correct at the top of the page, at the very beginning, write 100% on the first page of the lesson. Because I'm assuming at this point that you use more than 1 page to do your homework. So go back to the beginning where it says lesson 2 and write 100% when you get it done. All right, that makes it so much easier for your parents to check your work. And doing the homework is harder than checking the work, but your parents have a hard job too. So we want to help them out and make it easy for them to get it done. All right, done with housekeeping. Are you ready? Let's dive in. Let's dive into this avalanche that is lesson 2. We're going to start. Didn't we already talk about area? John gets into some philosophical stuff, and I don't want to bog down in that. Let's just review some basic formulas for area, because that's what we're talking about here. Okay, area is our topic. Area of a rectangle is easy. It's length times width, right? Where length is one side and width is the other. Typically, length means the longer side and width means the shorter side. It doesn't matter as long as you get one of each. The area of a triangle equals base times height divided by 2. Or another way to see the very same thing is 1/2 base times height. I tend to prefer this one. This is just the same. Whatever you want to memorize is good. Height can be tricky. So we have to review a couple different ways that triangles might be shaped. Now base is easy, because base is always the part that the triangle's sitting on. But here are 3 different kinds of triangles: acute, obtuse, and right. And each of them you're going to find the height in a different place, but there's a little trick that I use to always remind you where to look for it. Send a spider in to the highest part of your triangle, my famous 6-legged spiders, and have your spider drop a line down straight. It doesn't matter what kind of triangle you have, that will always steer you in the right direction. It will always show you where the height is. That's actually on top of, but I'm pretending. With this kind of triangle, the height will go right through the middle, or through the center, not necessarily the exact middle. It kind of looks like it there, but it doesn't have to be. The height is inside the triangle. With an obtuse triangle, the height will be outside the triangle. It's important to remember with these two that this little bit doesn't count as part of the base. This is the base here. Okay, the base is easy on this one. Okay, don't get tricked and try to include that as part of your base. It's not. And then on a right triangle, the height is equal to one of the sides. That's different. On these two, the height is not one of the actual sides of the triangles. And the base is easy here too. All right, so when you're trying to find the height on a triangle, send the spiders in, right? Okay. I'm gonna throw at you the area of a circle, which is equal to pi r squared. We didn't talk about circumference, but I'll just give you that one too. The circumference of a circle is pi 2r, where r equals the radius. Or it can be pi times the diameter, where, I said it. Okay? All of these formulas, I'm going to say the pictures too. This is all puffy cloud of knowledge business that needs to be in your formula pages. This may be review from lesson 1, but I want to make sure you have it in front of you today because we're going to put it to work. Volume is a much simpler proposition because all volumes are, I'm footnoting this ever so briefly, but most volumes are exactly the same. We take the area of the base and we multiply it by the height of the object. Okay? Please, please, please. I abbreviate that as AB times H. V equals AB times H is how I'm going to write that. Okay. When we want to find the volume of a cone, we change it up slightly. We multiply 1/3 times the area of the base times the height to recognize that we're carving away most of that cylinder. When we do a sphere, it's 2/3. Okay, so there's some good volume information for you. Surface area is different. For surface area, we don't have an overall calculation like that. What we do is we add up the area of each side, right? Areas. We're going to do some of these problems so you'll remember what I'm talking about. This is my magic wrapping paper thing. It's also the object is made out of cardboard and we take the box cutters and we slice it up into different sections. All right. Volume works, this volume formula works even if we have wonky tipped objects like this. These are not right shapes. Right shapes are shapes where the side meets the base at a right angle. That's what we do most of our work with. These are wonky and we don't spend much time with these, but this same volume formula will work for them. And I think we might have a problem like that. We'll see. All right, let's try a problem. Example 2.1. the base of a right cylinder, okay, when we hear right, we know that's good news, 10 centimeters high, aha, h equals 10, is shown. Find the surface area of the right cylinder. Dimensions are in centimeters. Okay, I don't have enough room to work this problem. I'm gonna do it anyway. And it's like this. Okay? This is the looking down at it. They're not quite proportional, but that's okay. Okay, so what we have to do is we have to find the area of the top, the bottom, and then this sideways thing. Okay, so the area of the top and the bottom, you would agree, are the same. It's the same on the top and bottom. So how do we find the area of this? We break it up into the different components, right? So first we'll do the area of the rectangle, length times width, and that's 6 times 5, so that's 30. Then we have to find the semicircle. For the area of the half circle, we'll do pi r squared divided by 2. Notice this format that I'm using, even though it's kind of squished here, and I usually write it bigger, I always do it the same. I write what I'm finding, what the formula is, I plug in my numbers and I simplify. Please use that format. Okay, so now we're filling in for this. The radius is 3. I check the problem to see if John is going to leave the pi symbol in or actually multiply it through. He's multiplying through, so I will do the same. It's going to be 3.14 times, our radius is 3, so that's 9, divided by 2. Now I need to simplify that. I'll do it up here. What I'm going to do is I'm going to take 3.14 and I'm going to multiply it by 4.5. 9 divided by 2 is 4.5. That allows me to finish this calculation in one step instead of multiplying by 9 and then dividing by 2. It's not good. I guess I could go in evenly here, but I'm just going to take that step. I'll reduce these two to 4.5 and then do 3.14 times 4.5. And here it is. Does that make sense? You don't have to do it that way. If that just seems weird and nutty to you, by all means, do it the way you like. But let's go ahead and simplify the area of the half circle. Oh, I put my decimal in the wrong place, but there it is. Okay, so what I calculated is that the area of the semicircle is 14.13, right? So now we've calculated one of these surfaces. We've got the rectangle and the half circle right here. We add them together, we get 44.13. And then we need to double it, right? Because we have two of them. We have the top and the bottom. Okay? So that's the top and the bottom. Now, let's get a total. 88.26. That's cool. Now we need to find the lateral surface area. So we get our box cutters. I'm just going to squeeze this problem down here. We get our box cutters and we lay it out nice and flat like this, right? It's magic cardboard, so it cuts nicely. Let's say that we cut it at this corner so that we can kind of figure out where the folds would be and identify how this works. So this first section is 5 units long, and then it's 6 units long, and then it's 5 units long. Now this section, in order to figure out how long that is, we have to find the circumference of this half circle. And so we say pi 2r divided by 2, right? Because it's a half circle. Those cancel, so all we have to do is multiply 3.14 times the radius, 3, and this we're getting the circumference of the half circle is what we're doing here. Right? 3.14 times 3 is going to be the length of this section. I'll go up here to multiply. You might be able to do that in your head. By all means, do. 9.42. That is the length of this last section, 9.42. That's the length of the curvy bit. All right, so now we can add all of these together because we're trying to find the length times the width of this rectangle, right? The length is going to be, see, there's 10, 25.42. Is that dimension? Now, how high is this? Oh, there it is right there. It's 10. So that means that the area of the sides is 25.42 times 10. Which is, sorry, I was looking ahead at the answer and John's slightly off for me and I was trying to figure out why. But you know, one thing at a time. So we take 25.42 when we multiply it by 10, and that's 254.2. So there is the surface area of our sides, and there's our top and bottom. So now I'm going to flip over because this has really gone much too far. 254.2. That was the sides. And then top and bottom was what, 88.26. And we add them together. 6, 4, 2, 342.53. Just double checking that. We're off by a few decimals. And I'm not exactly sure why. John got, I know exactly what the difference is. This is exactly the same. John got the same as us for these numbers. For this number, he got 254.25. Oh, and here he got, this isn't exactly the same, I lied. He got 88.28 instead of 26. I'm not sure what he's doing there, why his numbers are ever so slightly off. His calculation is shaped the same way as ours. So I'm gonna call this good. I'm gonna put a unit on it, and I'm gonna remind myself that surface area is always a square. I'm gonna call that good. And I'm gonna find out why the decimals were off, and I'll get back to you in another lesson. I'm not gonna slow us down now to figure out why we're off by a couple hundredths of a point. He must have multiplied pi using a different number of decimals than I did. That's the only thing that makes sense to me. But this is the right answer, so yay. Okay, let's go on to another problem. This one's fun. It's a big plus sign that's even. Mine's not going to be perfect, but each of these lengths is supposed to be exactly 2. And then it goes back by 6 units. It's fun to draw. And remember, I know I've told you this before. I've told you guys everything before, so it's all hearing it again. But drawing the shapes is a really great way to prepare for doing the problem because it helps you focus on the details. And I highly recommend. If you can just glance at the picture and immediately know what's happening, which isn't very likely at the level we're at, that's fine. But more often than not, it's helpful to draw the picture. Okay, all of these are all 2s. All these inner, all the way around. Okay, I'll just keep drawing, but you might feel like that's overkill. I mean, maybe it is, but what's wrong with a little overkill, right? So what we want to do is find the surface area of this right prism. Okay, let's start by doing the front and back. We want the area of the front and back. That's usually the easiest way to start, is to do the 2 more irregular faces and then box cutter and take that. Okay. Each one of these little squares is 2 by 2, right? So it's 4. The area of each of these squares is 4. Pretend this drawing's perfect. It's not. And then there's another 4 in the middle. Would you agree? So that's 1, 2, 3, 4, 5 blocks of 4. So that would equal 20. And we aren't given a unit, so we just say units. Okay? I don't usually put the units in the middle of the problem, but I am this time because it's complicated. Now, let's do area of the sides. We take our box cutters, we cut all the way around this like so. We've got all these little folds in it. Let's figure out how many different sections there are. Let's say we started cutting right there. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going hard on this picture. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of these little sections, and each one is 2 inches long, right? Again, going very hard. I don't necessarily expect you to lay it out like that in your homework. That's a lot. Okay, so what that means is that this is 2 times 12 is 24 units in this direction. And how tall is it? There it is, 6 in this direction, right? So to find the area of this, it's length times width, length time width. Oh, that's really hard for me to say. 24 times 6 is 144 units square. And so our total is, oh, I see what I didn't do. This is correct for one of these faces, but we have 2, right? We have the front and the back, so I need to add another 20 units. Right? 1 for the front, 1 for the back. So when I add them together, I get 184 units squared, and that is the surface area of this beastly giant plus sign. That's the correct answer. Sometimes, however, John will not ask you for the surface area. He'll ask you for the lateral surface area. Oh, so sly. What that means is that you only have to do this part, right? Lateral means side. So if he only asks for the side, that means you only have to do this part. You don't have to do the front and the back. All right? So keep that in mind because sometimes he slips that into the problems. You already know this. I'm sure you've been through this drama before. Right? Yes, it's true. Okay, let's move on. Let's talk about cones and pyramids. Yeah, I know what you're saying. You're saying, but why? We tossed, yeah. I tossed this out to you before. Let me just add. This formula works for a pyramid as well, right? So with cones and pyramids, we carve it down to just 1/3. All right. So example 2.3. The base of a cone is shown. The dimensions are in meters. You know I like to do that just so I keep track. If the cone is 6 meters high, what is its volume? All right, volume is what we're trying to find. We know it's area of the base times the height. We know that if it's the volume of a cone or a pyramid, we take that and we multiply it by 1/3. All right, so we have to find the area of the base and the height. Oh, well, we've already got the height, so that's nice. And then we'll just multiply it by 1/3. That's cone or pyramid. It looks like corp, which is confusing. Let's draw a picture of this base, though. My cat's crying for food, so I might have to go help him. We'll see if anyone else does first. All right, so we've got our classic rectangle stuck to a semicircle business here. Okay, so let's see. 3, 2, and then that makes sense because the radius would be 1 and 1, so there's another side that measures 2. This would be 3 down here. Okay, we've got what we need to find the area of this. First, we find the area of the rectangle. That's length times width, and that would be, in this case, 2 times 3, or 6. Notice this format, I always use the same. Sometimes I stretch it out and fill out the page, sometimes I squeeze it, but I write the component that I'm looking at, the formula, the specific numbers, and then I simplify. This, the area of the semicircle, is pi r squared divided by 2. This is the one where it doesn't cancel. Circumference, it cancels. So that becomes 3.14, that's pi, times the radius squared, well that's 1, oh that's cute, and we divide it by 2. So really what I'm saying is ignore that and just divide this by in my head, and it's 1.57. Right? So the area of the base is 7.57. That's the area of the base. Now I've got everything I need for this. I'm going to say the volume of the cone equals, and I'm going to bring this back. I wrote it on the right side this time because I didn't have room to squish it in there, but I like to put the fraction first, times 7.57 times, what's my height? 6. And you can do it like this if you prefer. Dots are kind of old school for us. All right. Yay, this is looking good. Now, look, we can cancel the 3 into the 6. Don't forget to do whatever you can to make it easier. And so now it's just a question of doubling 7.57. I'm going to write times 2 underneath it. So the volume of our cone equals 15.14 meters. Volume is always cubed. Make sense? Yay! Pyramids work exactly the same way. We use the exact same formula. Spheres work almost the same, but we use a fraction of 2/3 instead of 1/3. we already covered that and wrote it down. So I'm not going to keep ranting about that. Surface area of cones. That's a little bit of drama. These calculations drive me crazy because we really don't use them very much. We don't build on them. They're not particularly useful in the other things that we're going to do, but still we study them. And if you think this is annoying, I just taught the lesson for Algebra 2, and it's all this same content. So I'm teaching it twice. All right. We mostly talk about right regular shapes. Okay, what that means is that we have a base, and then we have a top, and this comes straight down and makes a right angle with our base. Pretend it's perfect, all right? And then the rest of the cone comes like this. Pretend that is perfect, okay? This is helpful to have our cones oriented perfect and straight. It is a simplifying factor that makes our work much, 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 much easier. So we want that. Now, to find the surface area of a cone, we don't need to memorize this as a formula, but we can write it as one. The surface area of a cone is equal to pi r squared. Oh, that sounds familiar, right? That's the circle at the bottom, plus pi times the radius times what we call the slant height. The slant height is the curvy bit. Okay, that's an arrowhead. It's this edge. Okay, it's the side of it. If we have a cone that is based not on a circle, but on a straight-sided object, right? We can do that. What you do is you draw the base, you put a dot up above, and then you connect all the lines to it, right? That's kind of how you can see what it is. If we have this kind of a shape, the slant height is not on the edge. The slant height is in the middle of the panel, okay? It's centered on the face of the shape, okay? This one's different because it's rounded, so we don't have edges, but if you have edges, it's not on the corner, it's in the middle of the triangle. Do we have a problem like that? Yeah, we do. We have a couple problems that are like this, and then we'll have one problem like that. So let's review them, and you will see the difference. Okay. The radius of the base of a right circular cone is 8 centimeters. Okay, so this is how it looks. Comes down to the middle, makes a right angle, it goes over like that. The radius of the base is 8 centimeters. So that's that, right? That's the base of the thing. The slant height of the cone is 10 centimeters. So they're just telling us that, and it's centimeters. So it would be, that would be this dimension, okay? But John just tells us we don't have to figure it out in any way. So we'll use this and copy this one into your notes. It's a very complicated cloud. We're going to use this to solve for this. So it is 3.14 times the radius squared. The radius is 8. Lordy, it's 64, right? But this one, I just want to say, John does not use the actual numbers. He just leaves it pi as the symbol. So we're going to follow his lead on that so that our answer will take the same form as his answer. And then we're going to add to it pi times the radius, which is, what did I say, 8, times the slant height, which is 10. So this is going to be 64 pi plus 80 pi. And that means our final answer, the slant height of the cone, equals 144 pi centimeters squared. Surface area is always a square. Oh, that's not so bad, right? As long as we know the pieces. Obviously, this is the base, and this is the like hat part of the cone. And we're just adding them together. This is familiar, this is different. Okay, not so bad. Let's try this one. It's kind of fun. It goes backwards. We have a similar picture. There's our cone. There's our base. There's our radius. The volume of the right circular cone is 6 pi centimeters cubed. Wait, that's the answer. We're working backwards on this one, kids. The height of this cone is 2 centimeters. It's very squishy. Find the radius of the base. Oh, so John he's making us work backwards. Now, we just did a problem on surface area, but we're not doing surface area. We're doing volume. So we have to remind ourselves, volume of a cone, what's that? Okay, that's one where we just take 1/3 times area of the base times the height, right? I go back and forth between uppercase and lowercase. That it doesn't mean anything, it's just me. Okay, so let's plug in what we know and solve. The area of the base is a circle, so this is going to be pi r squared. So I'm just going to bring this over a little bit so I use my page better. The volume of the cone is going to be equal to 1/3 times pi r squared times the height, which is 2. And we know the volume of the cone. So I'm going to put 6 pi equals 1/3 pi r squared, and I'm going to put 2 in its own parentheses so it looks more normal to me. Do you see what I'm doing? I am setting this up so we can work backwards. The first thing I want to do is I want to get rid of the pi's. I don't like them. So I'm going to divide both sides by pi. Let's just get it out. It's on both sides. We can easily get it out. Now I will copy the problem over at the top of the next page. Six equals 1/3 times r squared times 2. I'll put these in parentheses just so it's not confusing. All right, that's just carrying it forward after we got rid of pi. Now, I would like to get r squared by itself, right? So I have 2 pieces that are being multiplied by it. What I'm going to do is I'm going to multiply by the reciprocal of both of them. So then the 2's will cancel and the 3's will cancel. I have to do it over here as well, right? Okay, and now, if I simplify this, I'm going to do the 2 against the 6 and get a 3. And look, it turns into 9 equals, this is gone, r squared, all of that is gone. And look, r equals 3. The radius of the circle has to be 3. And, is that right? Yes, 3 centimeters. A good question to ask is, well, if we're simplifying this, couldn't it also be -3? And algebraically, yes, -3 is one of the roots of this, but we're working in geometry. So could the radius of that circle be -3? No. So we can discard the negative root, which we can often do in geometry, and it is one of my favorite parts of geometry. So we worked backwards to find that the radius was 3 centimeters. Yay! Okay, one more in this category before we move on to spheres, and that's our last category, so we're almost there. Okay, example 2.6. The base of a regular pyramid is a square with each side measuring 4 centimeters. Okay, so we're going to draw a square as best we can. Doesn't have to be perfect. These are all 4. And then it goes up to a point. Hi, Grace. My dog is here. She's helping. Cats are meowing. There's just all kinds of pet revolutionary behavior around here. Grace, I'm almost done, but I have to do spheres. I'm petting her. You have to chill just a little longer. Good girl. Drop. Oh, she's being offered a treat. Okay, so here is our pyramid, which behaves like a cone, more or less. The base of a regular pyramid is a square with each side measuring 4 centimeters. Funny that I would get distracted, isn't it? The slant height of the pyramid is 5 centimeters, so we can just say L equals 5. Remember that what that means, here I'll use a different color. When we measure slant height, we're measuring in the center of each panel. Not at the edges, but in the center. Okay? That's an important distinction because sometimes John will try to mess you up on that. All right. The slant height is 5. Find the surface area of the pyramid. All right, surface area of a pyramid. It is going to be the base plus each of the triangles, right? This isn't a formula. This is just me thinking out loud logically how to do this, right? So here's the thing. We can find the area of the base. That's a rectangle. It's really a square, right? But it's length times width, and that is 4 times 4, and that is 16. I'm using the full page. Now, we have 4 triangles, right? They're all the same size, so I can calculate them the same. The area of a triangle is base times height divided by 2. The base of each triangle is 4. The slant height is going to give us the height, right? Because it goes from the center straight down. So the slant height is very useful because we need it to find the area of the triangles. So that's 5 divided by 2 because that's the formula. But then we need to multiply this by 4, don't we? Because we have 1, 2, 3, 4 faces on this. Huh, interesting. Okay, so now we just simplify 4 against, or 2 against this 4. I'm simplifying to just get 2. This is 20, so 20 times 2 is 40. So the area of all 4 triangles is 40. Now I've got the base and I've got the 4 triangles. I'm ready to add it up. That is 56 centimeters squared. Surface area is always a square. And that's right. Yay! Are you still with me? You know what? As horrifyingly long as this lesson is, the Algebra 2 lesson that I just taught is even worse. Do you guys remember the A and the B lessons in the red book? They are so gnarly. They're so long and so boring, and they just keep going on and on and on, and you want to cry, but you can't. Well, you can. This one is not as bad as that one, even though it's a higher level. So be thankful. Spheres. Okay. We're going to talk about the volume and we're going to talk about the surface area. Okay? I wish John would just spit the formulas out. He's giving us all kind of psycho knowledge. Okay, the volume of a sphere equals, oh, that looks like minus, 2/3 the area of the base times the height. And sometimes we have to do a little extra work to find the area of the base, but we'll talk to that when we get to a problem. The surface area of a sphere is a ball, right? So how would you even wrap a sphere, right? Everybody knows if you're giving somebody a soccer ball for Christmas, you put it in a flippin' box, right? You don't try to wrap the sphere, that's too hard. But there is a formula. There's a shortcut to this too. Let me finish talking about this. The surface area, it's 4 pi r squared. All right, that's just what you do. John tries to explain it in the book. I don't think that's particularly useful. Just memorize it. This is exactly what we were doing to find the volume of our cones and our pyramids. But when we're doing spheres, you can rearrange this, and I'm not going to explain why, because I don't want to make you cry. But this formula also works. Okay? This can be condensed and combined with the 2/3, and that's what you get. So it's kind of a shortcut formula that saves you a little bit of work. We're going to use both of them, and I'll show you. Example 2.7. Find the surface area and volume of a sphere of radius 9 meters. That's really big. For a sphere of radius r, okay, first we'll do the surface area. 4 times pi times 81, right? And so that is squared. Oh yeah, I did square it. Okay. Sorry, I was confusing myself. And so now all we have to do, John leaves the answer with pi. So we'll just do this. It would be what, 324, right? 324 meters. Surface area is always a square. Bum, ba, bum. That's the right answer. Okay, that's the surface area of the sphere using that formula. The volume of the sphere, we'll use this one. It's 4/3 times pi, which we're going to just leave as pi, times the radius cubed. Oh, that's a much bigger number, isn't it? 9 cubed. I don't know 9 cubed right off. I know 9 squared, that's 81. I can measure it by 9 again. Okay, so it's 729. So it equals, let's go down. 4/3 pi times 729. What do you want to bet that 3 will go into that? I bet it does. 729 divided by 3. Goes in there twice. Goes in there 4 times. There it is. So 3 goes into 729 243 times. Oh my gosh, this is such a big number, isn't it? And then we have to multiply 243 times the 4. Oops. So this equals 972 pi meters cubed, because it's volume. That's also the right answer. Using these formulas is pretty fast. Remember that this is derived from this. If you ever wake up in the middle of the night and go, but how? How does this change from this into this? Message me and I'll explain it to you. But for today, I don't want to bog you down on that. Just trust me that getting from here to there works. Okay, and we have one last problem. Hallelujah. We've survived. Find the surface area of a sphere whose volume is 288 pi centimeters cubed. Okay, so what we have to do is we have to go from volume to surface area. Let's get those formulas back in front of us. Surface area is 4 pi r squared, and volume is 4/3 pi r cubed. So we can see that the link between these two is r. So we have to take the volume and we have to use it to find the radius, and then we take the radius and find the surface area. Does that make sense? Okay, so we know that this is equal to that. So we can say 288, the volume, we're plugging into the bottom one, equals 4/3 pi, oh, this should have a pi on it too, pi r cubed, all right? We can divide both sides by pi and eliminate it. In the future, you don't even have to show this as a step. You can just cancel it out. It's on both sides, it's good to go. But I don't want to do that too fast to make sure you understand. 4/3 r cubed. Now we want to get r by itself, so let's multiply by the reciprocal. 3/4, 3/4. Okay, this is all canceled and we just have the r cubed left. That looks really good. Now we have to simplify this. Let's try putting the 4 into the 288 first and cancel that way. 4 goes into 28 7 times. 4 goes into 8 twice. So I call that reduced. Then we have to multiply 3 times 72, and that would be what? 216 equals r cubed. What do you think of that? Pretty good, right? Now we have to figure out what r would be. What's the cube root of 216, right? I know it's bigger than 5 because 5 times 5 is 25 times 5 more equals 125. I don't know any other bigger ones, so let's try 6 times 6, which is 36, times 6 more would be 318. Oh, there it is, right? So this is 6 cubed. I just tested over here. I took a cube that I knew, and then I understood, okay, I have to work up from there. So we find that r equals, what did I say, 6, right? Okay, that's really good. That's gotten us this far along. We started knowing the volume. We backed into the radius, going backwards through the formula. Now we can solve this one straightforward because we know the value of r. So now we can say the surface area equals 4, and I look to see if John, nope, he just leaves pi in the answer, so we don't have to multiply by 3.14. Where am I? Here it is, r, times r squared, right? And r is 6, so that goes on there, right? So 6 times 6 is 36, and 36 times 4 is 144. So the surface area equals 144 pi centimeters. Surface area is always a square. We did it. We got all the way to there, didn't we? Is that the right answer? Yes. Holla. Great. I am going to be in touch with you. When I drop this link, I'm going to ask you to get back to me and tell me when you would like, what day and time you would like to do your video check-in. It doesn't have to be for the whole year, but at least to get us started, what would be helpful to you. All right, good luck with lesson 2. Enjoy your 2 days of homework out of it. I will chat with you on the videos very soon. Thanks, bye.